Welcome to College Algebra, section 2.3. My name is Gregory Carlson, and this is a very, very important section because, in fact, this is the very first lesson of calculus. If you take calculus, you will get all of this information repeated again, and so it's a very good idea to really put this in your brain for later. So let's talk about a few definitions really quickly. What is the difference between a relation and a function? And a relation, is basically a collection or a set of ordered pairs. And basically you can think of those as being points on a graph. But it could also be an equation. So a relation is just two things that are related to each other. In fact, the circles that we were making in the previous section, those circles are in fact relations because they relate x and y in some way. So some collection of points or even an equation can be a relation. So in that case, what's a function? A function is very similar, except there's one important difference. So the way I define function is similar to how they do it at the college level when you're getting your undergraduate in math. And I like to think of it as a mathematical rule which maps inputs to outputs. So this definition is a little imprecise, but it's going to work for our purposes right now. A function is a mathematical rule. You think of it as an equation. And what that rule does is it takes an input and it gives it to an output. So you can think of the function as being like a machine. You put in an input number and it spits out an output number. However, there's one really important rule that makes a function different from a relation. And that different rule, and this is very important, each input may only go to one output. And so in other words, if you put in an input number, you know that it's only going to go to one output number, one only. And so if you plug in 2 and you get 5, that's good. But if you plug in 2 and you get 5, or you sometimes get 10, then that means it's not a function anymore. Let's define two more words really quickly, the domain and the range. The domain is the set, which means collection, of all of the inputs. So all of the possible inputs of our function go to a set called the domain. And so the domain is like a basket. It's a collection. It holds all of our inputs. And so then you can probably imagine what the range is. The range is also a set or collection of all of the outputs. And so that's the idea. The domain is all the inputs, the range is all the outputs. Please, please memorize all four of these definitions right now, especially domain and range, because we're going to be talking about them over and over and over again in this class, and you're going to see them all again in calculus. So save yourself the trouble and memorize them right now so that you can just know these forever. So basically what we have with our function is we have our domain, our set of points, that's going to go into the function machine. And that function machine is going to do math to them and other things. And that is going to give us our range. So the domain goes into the function, which spits out the range. But each domain point can only go to one range point. It's okay that two different domain points could go to the same range point. That's okay. So like if 5 goes to 2, but 6 also goes to 2, that's okay. But what we don't want is for 5 to go to, for one input to go to 2 outputs. And we'll look at examples of all of this, so don't be confused. Let's just keep pushing. There are two major domain restrictions that we are going to see in this class. And so remember the domain, most of the time you should assume that the domain is all real numbers. The domain is every possible number with some restrictions. And the first restriction is, we've seen it already, a denominator of a fraction cannot be 0. So let's just look at a function that is all real numbers. This function, f of x equals 2x, there's no restriction on what we plug into x. There's no restriction on that. We can plug in any number, so the domain is all real numbers. And that's the case most of the time. X squared, you know, is another example. X to the third, sine of x in trigonometry. A lot of functions have domain of all real numbers. Now look at this function though. 5 over x minus 3. Well, this function has a restriction. It's undefined if the denominator of our fraction is 0. And so we don't want the entire denominator to be 0. In this case, it's actually okay if x itself is 0, but we don't want the entire denominator to be 0. So can you think of what point x can't be? Hopefully you got it. The only restriction in this domain is going to be positive 3. X can't be 3 because if it was, it'd be 3 minus 3 would be 0, and we can't divide by 0. Let's do another one. 3 over 2x plus 7. Again, we know that there's at least going to be one point that x can't be, one restriction on our domain, because the entire denominator can't be 0. So let's solve the equation. 2x plus 7 is 0. Minus 7 minus 7. 2x equals negative 7. Divide by 2, divide by 2. So we get that x cannot equal negative 7 over 2. Because if it was, then the denominator would be 0, and that would be undefined. So there's the first restriction on a domain. The denominator can't be 0. The second restriction is the values in square roots must be positive. So when we're talking about functions, for now we're only going to be interested in real numbers. So consider the function f of x is equal to the square root of x. Now I know I haven't really talked about what f of x means. For now it's just another way of y. It's just basically y. And we'll talk about it more later, so don't worry about it too much right now. What are the restrictions on the square root of x? Well, if we're only talking about real numbers and not imaginary numbers, we know that this can never be negative. And so it's basically x is bigger than or equal to 0 is the domain. The domain is x, it can equal 0. We can't, the square root of 0 is 0, so that's okay. And a lot of people miss that. But other than that, it's got to be positive. It's got to be bigger than 0. So what is the domain of this function? The square root of 3x plus 2. Well, we know that the entire square root needs to be positive. And so basically what we do is we just set up this equation. We set up this inequality. The entire square root needs to either equal 0 or be positive. So let's find out what values of x make that happen. Minus 2 minus 2. 3x is greater than or equal to negative 2. Divide by 3, divide by 3. Don't forget that if you divide by a negative, you need to flip this sign. The domain of this is going to be x is greater than or equal to negative 2 over 3. So we didn't need to flip the sign because we divided by a positive. So the domain of the square root of x is x has to be positive or equal to 0. In this case, we just solved this inequality to find the domain. And by the way, I should have written these in interval notation. So this would be in interval notation, 0 to infinity, 0 with a bracket. In interval notation, this domain would be bracket negative 2/3 to infinity. So those are the two domains of both of these. In interval notation, this one would be, if we're only not allowed to be 3, This would be negative infinity to 3 parenthesis or 3 to infinity parenthesis. If that's confusing to you, you should review the section on interval notation back in 1.7. In interval notation, this would be negative infinity to negative 7 over 2 or negative 7 over 2 to infinity. I'm a little over on time, and so let's do the next part in part 2. See you there.